Welcome to Chapter 9 entitled Analysis of Data. Statistical analysis, or statistics, is concerned with the development and application of methods and techniques for organizing and analyzing data. Role of statistics. Statistical analysis used to accomplish four basic purposes includes: 1. Statistics may indicate the central point around which a mass of data revolves. 2. They may show how broad or diverse the spread can be. 3. Statistics reveal how closely or distantly certain features within the mass of data are related. 4. They indicate the degree to which the facts occurred by mere chance. In short, the basic purpose of statistical analysis is to summarize observations or data in such a provide answers to the hypothesis or research questions. Cautions in using statistics. Researchers should be aware of other concerns in using statistics are necessary for most research studies involving quantitative data being particularly crucial at the sampling and analysis stage. The analysis process should be planned in advance in order to anticipate problems might encounter. The anticipation of the analysis process determines the kinds of data will be needed. The conceptual development of a research study should be dictated by statistical techniques to follow. Steps involved in statistical analysis. The establishment of categories. The identification or establishment of categories should take place before the data are gathered. 4 basic rules or guidelines should be followed. 1. The set of categories or values. 2. Each set of categories should be exhaustive. 3. The categories within each set should be mutually exclusive. 4. The development of categories should be based on a sound knowledge. Coding the data codes are, in turn, assigned to specified locations in data files, particularly if computer data analysis is planned. A codebook is useful for describing the locations of variables and for indicating the codes assigned to the categories or values of each variable. Analyzing the data. Descriptive statistics. Types of data analysis. Frequency distributions are usually reported in tables include simple or absolute, cumulative, percentage, and grouped distributions. Pictorial representations used to portray a variety of characteristics of the cases or individuals with respect to the variable or variables measured involves bar graphs or charts, pie charts, histograms, and frequency polygons. 3. Descriptive statistics are capable of characterizing what is typical in a group of case. Statistics, referred to measures of central tendency, include the mean, median, and the mode. 4. Measures of dispersion or variability. A descriptive statistics can indicate how widely cases in a group vary. 5. Correlational or associational statistics. A descriptive statistics can measure relationship between the different variables in the data. What is parametric and non-parametric statistics? Parametric statistics are based on assumptions about the distribution of population from which the sample was taken. Non-parametric statistics are not based on assumptions, that is, the data can be collected from a sample that does not follow a specific distribution. Some examples of frequently used parametric tests include the following. 1. Z-test 2, students t-test 3, difference of means 4, analysis of variance 5. Post hoc test 6. Reliability coefficient 7. Pearson's product moment correlation coefficient R8. Regression. Non-parametric tests. Common example as follows. 1. Chi-square test x22. Mann-Whitney U test 3. Wilcoxon sign TES 4. Spearman rank order correlation, or Spearman's 5. Kruskal-Wallis test. Selecting the appropriate statistical test. Cautions in testing the hypothesis. In using statistics to test hypotheses, always keep in mind that statistical inferences are based on probability and never rely on statistical evidence alone for a judgment of whether a hypothesis is true. It is also important to remember that a single statistical acceptance of a hypothesis does not prove it to be true. Analysis of non-quantified data. The analysis of qualitative data differs from the analysis of quantitative data not only in the nature of the data, but also in the nature of the process. Qualitative researchers have frequently suggested that research design, data collection, and analysis are simultaneous and continuous processes. Qualitative data analysis is the generation of concepts, involves immersing oneself in the data, looking for patterns, identifying surprising events, and being sensitive to inconsistencies.